In this chapter, you will learn about circular motion, 圓周運動. You have already learned linear motion, 線性運動. Linear motion is a one-dimensional motion. That is, a body always moves along a straight line. For circular motion, it is a two-dimensional motion, 二維嘅運動. That means the body moves on a plane, 圓周運動. Examples of circular motions are: first one, a car turning around a corner. Second, the moon revolves around the earth. Another example is the earth revolves around the sun. Let's look at some physical quantities in circular motion. Consider a body P performs circular motion at a constant speed or velocity v. Let O be the center of this circle, and let R be the radius of this circle. If at time t it moves from A to B along this circular path, the distance traveled during time t will be the arc length of AB. During this time interval, the angular displacement 角位移 of the body P would be from A to B. The angular displacement would be this angle theta. The angular speed 角速度 is defined as the rate of change of angular displacement. Which is equal to theta over t. The symbol for angular speed is omega. Therefore, we have omega equal to theta over t. The magnitude of the linear velocity or the velocity of the body during the time interval t will be v equal to AB over t, where AB is the line joining A and B. If the time interval is very small, that means if t is very small, which tends to 0, then the length AB would be almost equal to the arc length of AB. Therefore, we will have the linear velocity of the body is equal to v equal to arc length of AB over time t. Since arc length of AB equal to the product of the radius times the angular displacement theta, therefore we have V equal to r theta over t. Also, because angular speed is equal to theta over t, therefore we can substitute omega into theta over t. Therefore, we have the linear speed or linear velocity of a body equal to the product of the radius times the angular speed omega, which means the linear speed equal to radius times the angular speed. This equation is quite important. Now let's look at the centrifugal acceleration in a uniform circular motion. Centrifugal acceleration means 向心加速。Consider a body performs circular motion with a constant speed v. Even though the speed is a constant value, however, the direction of motion changes with time. As a result, we say there is a change of velocity of the body. Therefore, there must be an acceleration during its motion. That means whenever the velocity changes, there must be an acceleration. You don't need to prove the acceleration in terms of speed and radius. You only need to memorize the result as follows. For uniform circular motion, there must be an acceleration a. In fact, the magnitude of the acceleration is a constant value, and the magnitude of a is equal to v squared over r, where r is the radius of the circle and v is the speed of the body. Second, it is very special that the direction of the acceleration when a body performs circular motion with constant speed, the direction of its acceleration is in fact towards the center. This point is very important. That means when the body is at this point, moving to the right with a constant speed v, at this moment, its acceleration is towards the center O. A is towards the center. Again, when it moves to the point here, traveling with a constant speed, again v, in this direction. At this point, its acceleration is also towards the center of the circle. That means A is towards the center again. Again, when it moves to this point with a constant speed v traveling in this direction, its acceleration is again towards the center O. In all these cases, the acceleration is of magnitude equal to the speed v square, the square of the speed over the radius. Another important thing for circular motion is that the acceleration is always perpendicular to the velocity in circular motion. That means acceleration is always perpendicular to the velocity at any time. Since the acceleration at any moment is always pointing towards the center, we call this kind of acceleration centripetal acceleration 向心加速，即係話嗰個加速一定係指住個圓心。To denote centripetal acceleration, we always use this symbol AC. C stands for centripetal. We say AC, okay, which means centripetal acceleration. In this case, we can all use AC, 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 okay, to represent centripetal acceleration. By Newton's second law, F equal to ma. If there is an acceleration, there must be a force producing the acceleration. If the acceleration is called centripetal acceleration, then there must be a centripetal force 向心力 which acting on the body to perform circular motion. And the symbol for centripetal force can be written in Fc. We have Fc equal to mac. Centripetal force equal to the product of mass times centripetal acceleration. Example 1. A body of mass m performs uniform circular motion with speed v and radius r. Complete the following table. By using the equation AC centripetal acceleration equal to v squared over r and centripetal force Fc equal to mass times centripetal acceleration, we have the AC equal to square of 2 over 0.5, which is equal to 8. Fc equal to mass is 1 times A is 8 equal to 8. For the next one, A equal to 0.5 square over 1, which is 0.25. F equal to 2 times 0.25 equal to 0.5 Newton. 1. A equal to F over M, which is 10 over 2, which is equal to 5. And V squared equal to R times A. Therefore, V equal to square root of RA, which is 0.5 times 5. Two, a car is moving in a circular path on a road in a clockwise direction. Draw the directions of velocity and acceleration of the car at position P, Q, R, and S. The respective direction of velocity at P, Q, R, and S are drawn as shown, which is tangential to the circle. The acceleration is centripetal, 向心, therefore it must be direct towards the center. O.